Hello students, welcome to IMS Gate Academy and also welcomes all of you for the Gate Score Booster session. The first series, in this series we have started operating system. So one session like a part 1 of the operating system already we have done in the previous session only, okay. So most of you might have attended also, like if those who are not able to attend, you can also watch later, okay. The part 2 of operating system I would like to continue in this session now. And also as I said, like most of the subjects we are from the computer science branch, we are going to be cover upcoming sessions, like so you can also check for the schedules, like next week also we planned some more subjects like computer organization, computer networks and C data structure algorithm like DBMS, so which comes under upcoming weeks. So dear students, this is a very important session I could say. Why? Because this last moment, like almost we have 40-45 days time is there, like maximum time for the GATE 2025 exam. So this is very much important to know, like what are the areas student need to be emphasized on each subject and how we have to revise them. So that are the things going to be discussed. Okay, Yashwant, please take more, and yeah, definitely Yashwant, will try to take the more sessions, like definitely we will try, okay. So try to present the class. I have planned again 3-hour session today on operating system. The various things from the operating part 2 we are going to be covered in this session, okay. We will plan some other subjects too, okay. And quickly you can also share this link among your friends. They also can join live session and they can be discussed various things. And also it is free to ask, so any kind of doubt related to what operating system, okay. So part 1 done, like I have discussed from initial topic, what you can say, introduction part, process management, to most of the things done. So now in this session I will be taking from the deadlock topic and memory management and file system will be covering. So very good evening JP. So Matan, good evening, very good evening. Yashwant, good evening, okay. So good ma, good. So what about you, all of you? So I hope your all preparation going well. So be positive, be like what you can say, very active for this next 40-45 days. So try to utilize most of the time properly so that you can increase your marks in the GATE exam. And all of you try to share the link maximum students so that they can also join as a live. I hope JP and Mathan, those who watched last session, so definitely might have benefited for you in terms of looking at some important topics to get a clarity over this one. We tried. So those who are not watched, you can also refer like one more time the session. Okay. So coming into the point, deadlock. Okay. From this deadlock, in the GATE point of view, understand again we can expect 2 marks can be expected. Okay, let me write like 1 to 2 marks can be expected. Like, so most of the time 2 mark question framed. Most of the time 2 marks question framed. Sometime 1 mark question also framed like this. So this is most of the time 2 marks expected from this area. Okay. Some important areas in this deadlock topic we can cover it here. So we'll see first the basics, like definitions, understand the definitions like this, okay, followed by so various deadlock handling strategies, right, deadlock handling methods. So deadlock handling methods we'll observe it, okay. So what are those? Can you tell me what are the deadlock handling methods? So some of you might have revised. Some of you might have studied from the topic deadlock. What are the approaches we have for handling the deadlock? So one is a deadlock prevention. So one mechanism we have deadlock prevention. Okay, prevention. Okay. The second approach is the deadlock avoidance. Deadlock avoidance. Third one, we allow the process to enter into deadlock state. So thereby detect it, deadlock detection. detection, and there from there you have to recover this deadlock, recovery. The fourth strategy is deadlock ignorance, please understand. So, deadlock ignorance, fourth strategy is deadlock ignorance. Detection, recovery, ignorance. Yes, these are the main strategies which you can see to dealing or handling with the deadlock. So, one point you understand is the deadlock is the undesirable problem, is a major problem in the operating system. Okay, thus we discussed also in concurrency environment, IPS environment, a couple of times you might have experienced the situation of the deadlock, like where two or more processes holding some resource, especially in a multi-program environment, what happens, you know. So, any resource before using that resource should be scheduled. So, that means you understand a process required any resource, you should put a request to operating system. If that resource is available, it will be granted, you can use the resource and release. This is a model, system model. When a process requested for a resource, if the resource is not available that moment of time, eventually process has to wait, so it has to move to wait state until that resource comes. So, after some time operating system able to assign the requested resource to a process, again use the resource. Once the use is over, you can release this resource. The third case can happen when a process putting a request to operating system, if resources are not available, the process waiting, correct or not, the waiting process not able to change the state. That means the process which is request for resource which is held by other waiting process in that system. So, this kind of situation may circularly happen, many processes like a circularly formed, means in this circular queue each process holding some resource and waiting for additional resource which are held by other waiting process. The state or the situation we can define as a deadlock, deadlock. So, now deadlock definition if you see, let us take the scenario, process Pi is there, process Pj is there, like this. There are two processes available. Assumption. So, resource R assumption, one particular resource held by the process Pi and another resource, let us take Rj is here. So, which is held by another process Pj. Now, Pi holding a resource and require a additional resource, like one additional resource. So, that is suppose Rj putting a request for this one. Now, Pj also holding some resource, required additional resource. So, this is putting a request for this one now. So, what is happened? Hold and wait. The characteristic of deadlock, if you see, characteristics of, tell me what is the characteristics of deadlock, So, deadlock. So, how we can understand that there is a presence of deadlock? Accessing the resource must be what? Mutual exclusion, correct or not? So, any computer resource should be accessed by the process what? Mutual exclusion manner, meaning no two process should use the resource simultaneously, correct. Example, you take a printer, any kind of resource, at a time only one process can be used, mutual exclusion. Now, there is a situation should be holding a resource holding like held by some process, also the process waiting for some additional resource like wait and hold and wait. The third one understand now. So, this understand. So, this hold and wait may be forming circularly, circular wait. Now, in this moment preemption is not happening, like preemption not occur, like no preemption occur for the resource, not to the process. So, no preemption now. If these are four conditions are simultaneously present any situation, that situation liable to suffer like into what? Deadlock. Yes. If there is a deadlock, please understand, if there is a deadlock problem, this all four persons or four condition must be present. Now, only this condition present, suppose example, every hold and wait you cannot tell a deadlock, correct or not? Every circular wait also you cannot tell as a deadlock, correct or? Am I right or not? So, presence of all four conditions we can tell there is a deadlock. That is what we can say. Necessary and sufficient condition to declare the state is a situation is called deadlock. This four. You see, accessing a resource is mutual exclusion, they have hold and wait, each process have hold and wait. Now, the process Pi waiting for process Pj to release Rj. while process PI is waiting for PJ is waiting for PI to release what RI. This is not going to happen. That's what we can say. Two or more processes are said to be under a deadlock if and only if they are waiting to happening of an event which could not occur, which could not happen. They are waiting to change the state, so that state not going to be changes. This situation we called what? Deadlock. This we can call deadlock. Other area also we can tell. Other area also we can tell. Suppose example, in a synchronization mechanism we have studied process, suppose P0 and P1 is their assumption. So there is a binary semaphore variable, binary semaphore, let's take A equal to 1 and B equal to 1 is here now. So these two processes want to access the critical section and enclosed by, suppose example, some semaphore operations P of A followed by, so P of B. So now followed by here also P of B, let's take followed by process P of A assumption now. So they want to enter the critical section now. This is instruction 1, instruction 2, instruction 1, instruction 2. If preemption happen after every instruction when the process is running, so this situation is creating a deadlock or not? Just observe and tell me all of you. If when a process P0 or P1, one of them scheduled it, so one of them if we scheduled it, please understand, one of them is scheduled it. If each process get preempted after running off each one instruction, so then therefore what happens? This both process get blocked. Blocking nothing but processes will move to secondary memory, they are not able to come out. Therefore we can say the situation becomes what? Deadlock. Am I right all of you? This situation will create deadlock or not? This situation will create deadlock or not? Everyone tell me, tell me. Required response, make it as an interactive session, all of you. Yes, yes. So that's what I am telling. This is a situation where we say the deadlock, all are present, situation, the 4 conditions are present here. Yes, both are not able to use the resource, they are not able to enter into critical section. The situation we can tell deadlock. Okay. So this is not desirable thing. So we should not allow the state of our situation should occur in the operating system. I must handle it. So various handling mechanisms we have, right? So various handling mechanisms we have. The first one, if you see deadlock prevention. So deadlock prevention. What is the prevention says? So it is definitely now deadlock will not occur here. So deadlock, please understand, deadlock will not occur under this one, not occurs, deadlock will not occur. Deadlock will not occur. What did this says, So prevention says what? You understand clearly. If 4 conditions are simultaneously present, that situation we say deadlock. If one of the condition is not present, we can declare there is no deadlock in the system. One of 4 condition is not present, so definitely we can declare there is no situation of deadlock, correct or not? Yes. Eliminate one condition means prevention, very good. Elimination or negation of a condition, one condition, so can be prevent deadlock. So we have various conditions we have, correct or not? One is mutual exclusion, we have studied. Hold and wait is there, Third one is a circular wait, and the fourth one is a no preemption is there, so dissatisfy one of them, Let's try mutual exclusion. I want to dissatisfy. Mutual exclusion, dissatisfaction, meaning what? Allowing more than one process to use a resource, correct? So mutual exclusion refers no 2 processes should use the same resource simultaneously, means only one process has to use a resource. So now dissatisfying, negating mutual exclusion, nothing, allowing more than one process to use a resource. So that nothing but all non-shareable resource need to be converted into shareable. Is it feasible if I convert non-shareable to shareable? Can we convert non-shareable resource to shareable? Think, answer all of you. So negation of the mutual, oppositing, correct, or negation of the mutual exclusion, dissatisfying the mutual exclusion, breaking this mutual exclusion, nothing but allowing it. We have to allow it, correct or not. We will allow it to more than one process to use a resource. Is basically you are violating this mutual exclusion requirement, right, which you studied from IPC synchronization. We have seen last session. So IPC environment, we said clearly to use the resource or access the resource, it should be mutual exclusion, must be guaranteed. So we cannot dissatisfy this one, right. Now what is this hold and wait, please understand. So breaking this hold and wait, negating this hold and wait, dissatisfying negate hold and wait, nothing but there must be hold and wait, hold or wait, correct. There must be either hold or wait for the resource. So both should not be present, that is what negation, correct or not. Either I should have what, like no, hold or wait, correct or not, all wait. Can you tell me, we are giving some two protocols we applied for this one to dissatisfy this condition. So we are giving two protocols. What are these two protocols or rules or some conditions we are keeping to break hold and wait? What are those? Tell me all of you. What are the two essential conditions if I keep it so that hold and wait can be dissatisfied? Therefore, I can prevent the deadlock. By using this mechanism, I can prevent deadlock. So either you hold it means, please understand, rule number 1. A program, please understand, should acquire all the required resources, So before making the new request, please understand now, I repeat my statement. A process should acquire all the required resource before commencement of its execution. Therefore, you cannot ask middle. So you are only holding the things, you are not like putting a request in middle for the additional resources. So therefore, only hold and wait will be there. So now only hold is there. So definitely we can say dissatisfy this condition, correct or not. That means assign all the resources to a process in advance only. But it is little more restriction, because what happens if you advance all your resources, you keep it, what happens? Other process may get starvated which are required. And also resource utilization is less, correct or not. Inefficient utilization of resource also we can tell. Why? Because you are holding advance only which is not actually required immediately, correct or not. It is also implies what? Inefficient utilization of resources and also creating a problem what? Starvation to other processes, right. This is rule number 1. What is rule number 2? Says little relaxation given. So do not require to acquire all the resources in advance. You take it some required one. In middle also you can put a request. But when you make a new request, first you release the held one. That means, so release the resources before making a new request. Rule number 2. Release the resources before making a new request. So with this one you can understand resource utilization can be proper. Why? Because you are not holding all the resources in advance. Other process may not be getting the starvation. Only problem can be faced with the rule number 2. Same process which release the resources and making new request may goes to a starvation. Why? Because in the moment you release the resources, nothing but operating system may assign this resource to other process. Now when you make a new request including old one, so this old resource may not be available immediately given to other process. So the process has to wait for some time to available, that nothing but same process may get starvation. So only starvation problem will be there. There is no problem of inefficient utilization of the resources. Here is both problems are there, but ultimately we are able to solve the problem of what? Deadlock. Deadlock prevention can be done. So I can say by using this hold and wait, deadlock prevention can be done. So we can use a hold and wait condition to dissatisfying the, we can dissatisfy or not. So come to the point of circular wait. Okay. How to break the cycle? How to break the cycle? Yes. Recall the things. How to break the cycle? Circular wait. How to break the cycle? Yes. So third condition we are saying that circular wait, right? Circular wait. How to break the cycle? We are using the linear order of the what you can say resource numbers. One rule we are going, never allow a process to request a resource. Never allow a process to request a resource. Okay. So whose number, resource number is what lesser than the last one requested assigned. Either you have to acquire the resources in an increasing order of enumeration, or in decreasing order of enumeration. There won't be like this increase and decrease in the same line, that may be forming the cycle. Meaning resources are numbered like uniquely, resources are numbered uniquely. Based on these resource numbers, so you have to verify, correct or not. Never assign a process lower number of the rest. It is not only like this, it can be increasing order also. I can go either increasing order or it can go in decreasing order. So both the protocol can be happen. So through which we can also break the cycle. If you are breaking a cycle, nothing but, so there won't be deadlock. I can use this mechanism also, dissatisfying this, therefore this can prevent the deadlock. Fourth condition, what is the fourth condition? So no preemption, right? No preemption, no preemption. Okay. So what you can do, preemption, allow process to preempt it. Yes or no? Getting my point? We allowed the process to preempt it, right? Preempt the resource. Suppose example, very simple situation. When a process putting a request to a OS for a resource, if the resource not available, same process can preempt the what you can, its own resources. You can preempt it and given to other waiting process. Self preemption we call. Self preemption of the resources by a process. So later you can acquire all the resources, then you continue execution. So there is another thing like by force, operating system also can preempt the resource or steal some resources of other process, can given to what the requested process, that also can happen. So allowing this preemption of resources can be dissatisfied this condition. Therefore I can say now this condition also can be used to what, preventing the deadlock. We can prevent the deadlock now. I hope this is clear. So therefore what I can say, 3 conditions eligible. So 3 conditions are eligible to, so now dissatisfying. So we can use these methods to preventing a deadlock. This important point need to be observed from this one. Okay. I hope this is clear. Everyone, any doubts are there with this respect? With this respect, do you have any doubt? Okay, chalo, second method, next one. So deadlock. So deadlock avoidance. Deadlock avoidance. So now please understand, it uses the 2 algorithm, resource allocation graph, and one more algorithm uses a banker's algorithm. So uses the 2 algorithms. Okay. One is resource allocation graph, second is a banker's algorithm. So resource allocation graph can be used to avoid the deadlock in case of what, single instances of resource type. So resource type. All single copy cases we can use a resource allocation graph to do it. How to do it? Very simple. Whenever request edge is converted into assignment edge, when request edge is converting assignment, make sure that cycles should not form. If the cycles are not formed, definitely we can tell this is not forming, it is not forming a deadlock, it is not creating a deadlock, you can say. Yes, correct, you are JB right. Single instance resource type, use bankers resource allocation graph. So now bankers algorithm can use what, multiple instances case. So multiple instances case. So multiple instances case. So how bankers algorithm works? Very simple, you understand. It required some prior information about a process requirement on resources. Every process must declare before their execution how many resource required in advance. You should just declare demand. So your demands should be now declare it. Based on the demands of each process and based on the available resources, now this bankers algorithm going to be apply some algorithm, internal algorithm. It is always check this state of the system whether it is safe or unsafe, please understand, safe or unsafe, getting my point. So whenever a system becomes unsafe state, indication might lead to deadlock, it will stop allocation. Sometimes this may create a problem also, bankers algorithm may create a problem also. Example, unsafe state when comes, maybe may not actually happen a deadlock, but whenever it becomes unsafe state, nothing but it is going to be stop allocation, correct or not? May not be occur deadlock, that we do not know, but it is stopping. Very, what you can say, very optimal algorithm also we can tell this one. It is avoids the deadlock, it completely avoids, and this deadlock avoidance is a less restriction than a deadlock prevention, because deadlock prevention we are emphasizing some rules So definitely we should follow, but here no such rules are there. Just we are expecting the process from, like bankers algorithm always expecting the from the process to declare your maximum requirement in advance. Based on your information only we are able to apply it. Now internally it will run two algorithms, correct? One is safety algorithm, please understand. One is runs what safety algorithm. The second one is it will also runs what resource request algorithm. Two algorithms will run. Safety algorithm, please understand, safety algorithm is going to be applied to find out the safe sequence is present or not. If at least if there exists at least one safe sequence, we can tell the system is safe state. When the system is safe state, we declare, then some order we can allocate the resource to a process. Therefore, what you can say, this system will not enter into deadlock state. I hope this is clear. So resource request algorithm, meaning, so in case of prevention, what we had done, so in middle you should not hold the resources and put a request, correct or not? Here is what process can hold the resources, you can put a request. You can middle, you can put a request, but we are asking that's what this request can be granted or not. It will run the resource request algorithm, you might not know. So when we are just pretending that resource given to a process, by pretending that resource given a process, then we are running this algorithm. Again safety algorithm will run. Each request we are running safety algorithm to find out the safe sequence. If you get a safe sequence, we can grant that request. If you are not getting a safe sequence, we are denying the request. You understand now. The process has to eventually wait for some time, again put a request. So that moment again we run resource request algorithm, again safety algorithm. So whenever very simple understand, whenever safety algorithm when you run, if you get a safe sequence, we can grant it, otherwise deny it. So this is how this bankers algorithm will work. So we'll see some couple of problems related to this one, okay, related to bankers algorithm, we'll observe it. So one more thing to understand, one point we should be understand here, okay, before going to problems here. Suppose scenario, one type of scenario can be expected, like you tell me all of you. So process may be request demanding for n number of resources. Whenever almost all the resources are given to a process, whatever they demanded, maybe most of the resource allocated, maybe except one resource. Suppose 10 process available, there each are demanded some number. For all the processes, all the demands, so maybe given all of them except one resource. Still these processes may involve in deadlock or not. After getting most of the resources also, process may enter into deadlock state or not. Respond all of you. Hello, required response. After acquiring all the resources which I demanded most, but except maybe one resource, because of this one resource process may involve in the deadlock. So that can be understand. Suppose example n equal to 3 process available assumption, n equal to 3 process available assumption now. So each process demanding, each process demands 3 copies of resource R assumption, R like 3 copies demanding. Like now question is that, okay, how many minimum resources a system should have, please understand, should have to avoid the deadlock, to avoid the deadlock. So second question can be expected, how many maximum number of resources a system should have should have to cause the deadlock. So this type of questions can be expected, correct? This type of question can be expected. Yes, yes, yes. As per this question, tell me, as per this question. So process P1, process IDs if I take, so maximum demand, process P1, process P2, process P3 is there, each demanding 3 copies demanding, right? Okay. Total how many resources should be there so that deadlock will not occur? Till minimum 7 resources to deadlock free and maximum 6 resources to causing deadlock. So you are saying, Pardasar is saying 2, 6, 1, 7. Observe. So I was giving a statement. I am telling you, processes may involve, in a worst case. What is worst case? After almost getting the resources, because of one resource also they can be involved in the deadlock. Please understand. Suppose might be allocation given. So we are not at all looking for the best case. He demanded 3, almost I given. Suppose only one less than I got given. So total already given 6 resources already given. Now are they unblocked state? Are they executing? Right now are they executing or are they in block state? Process P3, are they in block or are they continue execution? Already given 2 copy given, 2 copy given now. So because of one resource, please, and they demanded what? 3 copies, 2 copies only we got. So they need 1. We don't have 1. So they are in deadlock now. They are in deadlock. For this, suppose 1 extra copy given. This is a relief, you understand. So with this copy, if you give it, it will satisfy. You will release 3. Then I can use this one. So therefore, so minimum number of resources I should have, 7 copies I should have. Then I can declare that there is no deadlock. Deadlock will not occur at all. Now if you have a 6 copies, definitely deadlock will occur, correct or not? That is the reason. So maximum resource should have. So maximum number of resources is what? Resource are equal to 6. Deadlock will occur. So minimum number of resource should be 7. So the deadlock will not occur. Minimum I am writing 7. Why, sir? If I given 8, 9, 10, there is no deadlock. If I given 10 resource, there is no deadlock. Yes, exactly. It is like, so that is, so dining philosopher problem itself like causing a deadlock, correct or not? Everybody holding the fork something, they are waiting for one, right? So that is not available, right? Circular wait, correct or not? Yes or no? So come to the point, this type of question can be asked here. So we have understand. So can we generalize it? So now suppose m resources are there. R is a suppose n processes available assumption. N number of processes are there. Processes, if I take it, now minimum number of resource should be there. Now suppose D I am taking demand of, okay. So demand of each process for a resource requirement. So m must be, minimum should be what? N processes, their demand, correct? So like n processes, right? So what should I do? N into D, each process we should, how many subtraction I should do it? So each process demanding D assumption, or like suppose this maximum demand is what? Summation of D I can take it, summation of D, correct or not? So all demand minus sum of all demand minus n plus 1, can I say like this? Will it make sense? N into D minus 1 also will work. D minus 1 copies, yes. This also can give a correct? Is it satisfying the condition? Yes or no? Tell me, all of you. Or m must be greater than or equal to n process are there, their demand minus 1 we are giving 1 extra copy, correct? So 2 into 3, 6 plus 1, correct? So this also giving, correct? Verify, all of you, will it make sense? All sum of all demands minus what? N copies, because N process available plus 1, correct or not? So this gives a minimum number of resources should be there in the system, so the deadlock will not occur. To causing the deadlock, I should remove this one, correct? Yes or no? Causing this deadlock, this one you have to remove. Based on this, so a couple of questions they asked in, please understand. This is generalized statement, you can use it. So one of the statement, like one of the parameter can ask, other parameters giving, one of the parameter can frame into question, right? Okay. So this part I hope it is clear, everyone. So this part is clear. So let's move on to some questions related to this one. Just attempt, what is the answer for this question, all of you? Yes, what is the answer for this one? Yes, ma, try it. So very good, very good. I am just stopping. Option A is right only, correct or not? So operating system have 13 tape drives, R equal to 13 copies we have. There are 3 process, P1, P2, P3, right? And maximum requirement is P1 is 11, P2 is what, 5, P3 is 8, correct or not? P1 allocated 6 copies, P2 allocated 3 copies, and P3 allocated 2 copies. Remaining need is what, 5. So 5 minus 3 is 2. This is 6 need is there, correct or not? So allocation, this allocation, correct or not? 9, 11. So 11 allocated means available resources. Available copies are 2. With this 2, I can only satisfy P2, correct or not? We have to start with the P2. P2. So P2, if I give it, what happens, available allocation you take it. No, I am giving 2 nothing but release 5. So 2 plus 3, 5 you can write it. So 5 nothing but okay, only P1 can be assigned, P1. So 5 plus 6, 11. So 11 means what, this I can assign it. So process P3, correct or not? P2, P1, P3, P2, P1, P3. Yes, absolutely. Option is right. Easy question. Right. We'll try one more question. So now just as I told you, so IMS Gate Academy, we are offering the test series plus, so for 20% discount. So majorly, so you understand, apart from the test series, major things you are getting, booklet you will be getting. 33 years, those who are watching and who are going to watch this video, observe it. 33 years of the PYQs booklet, physical copy you will be receiving, which contain the most of the gate questions and their solutions, audio solutions, even like alternate solutions, video solutions also we have. Among this, So like the doubt portal session support will be getting. So you can have other things also. The beneficial open it. Hello my dear students, can you please check my voice and video is part is clear? Extremely sorry ma, because due to technical glitches it got middle interrupted. So we are continuing the session. I hope everything is clear everyone. Okay ma, thank you so much. Now looking into another question from Deadlock only, you can see the consider a system in which a total available memory space is 48K and in which a memory is once allocated to a process cannot be preempted from that process. So there are three processes A, B, C have declared in advance that maximum amount of memory they will require what. So 25K, 15K, 41K words respectively. When these three processes are all in executing using this or the allocation of the word memory respectively, which of the following requests for additional allocation can be granted with a guarantee that deadlock will not occur as a result of the allocation? Try is also one of the good question we can say. Try this question all of you. Try this question. Yes, how many people tried? I hope all the options are visible. Option A process A request 9K words. Option B, C request 7K words. Option C, B request 6K words. Option D says A request 6K words. So which request going to be granted? So which request going to be granted? Yes, how many people answered? Yes ma, try da. A, C, D. Okay, we'll take given information. So processes, there are processes. Okay, we have three processes, right? Process A, process B, and process C is there. Process A, process B, process C. Okay. Yes, 3 processes are there, right? And the maximum amount of memory they will be required 25K, 15K, 41K demand. So demand of each process. So demand of each process is 25K, correct? 25K. 25K, 15K, 41K. 15K, 41K, they are demanding, correct or not? Allocation, they are using nothing but allocation only, right? Using nothing but allocation only, correct? So when 3 processes are all executing using 3K, 9K, 24K words, 3K, 9 kilowords, 25 kilowords, correct? 25, 3, 9. So did you find the need vector as well as what available vector we need to find out, correct or not? So we have to apply resource request algorithm also, correct or not? A resource request algorithm we need to apply. So need how many? What is the need value? This is 22K required need, correct or not? So 9 nothing but 6K required, correct? 6K required. So 25 means how many required here? If I remove 41 minus 25, this is 6. So 16K. Am I right? 16K only? 16K required it. Allocation happen, how much allocation happen now? 25, this 28, 37K is allocated, correct? So 37K allocated? Yes, yes, all of you? Next, available how much? Total how much memory space is? 48K is there. 48. So 30. So now how many will be available now? 3. So 3 plus 8, 11K is available, right? 11K is available. 11K available. Same thing done. Allocation, you can see 48K. Yes, 48K is there. Out of which we have allocated. 37. So now we have 8 plus 3, 11K is available. So what are the requests can be granted? Sir, allocation for C is 24K. C is 20, okay, just let me check one more time. Okay, sorry, 24K. This value is 24. This is 36, right? 36. Is it not? So 36 means we have available will be available will be 12K, correct or not? 12K. So now first request we are searching option A. If you take option A says request option A. What option A is talking? A request 9K words. A request process a request 9K words. So 9K words, whether it is granted, option A granted. So 9K. So process A is it should be always request must be less than of need, correct? Resource request algorithm you have to run, correct? Request of a process must be less than of need. Its need is 22K, correct or not? Yes. So this value is what? What is this value now? Request value is 9K is less than only. So if I given 9K, if I given to 9K process A, so now how many available here? So 9K if I given it will be 3K. With this 3K I cannot get it sequence, correct or not? Can I get the sequence when I pretend to allocate for a request A? Can we get a safe sequence, all of you? Can we get a safe sequence? Because after giving 9 available, you reduce to 3K. With this 3K, we cannot satisfy any one of them. We cannot satisfy any one of them. So therefore, we can say this option A is incorrect, correct or not? So option B says, what is option B? C request 7K. C process C request 7 kilowatts. So what is the C? C need is what? 16. So less than 16, that's fine. If I given 7K, available with me 5K will be available. With this 5K, so still you are not able to grant, you are not able to satisfy any request, correct or not? So therefore I can also conclude This also incorrect? Yes, all of you? Is it correct? Respond, those who are watching. So request C also cannot be able to grant it, right? Option C. So option C says B requests 6 kilowatts. So process B requests 6K. So now look, this the point. Process B, yes, need also 6K, you can request. We can request here. If I given this 6K available will be here. Now need is going to be reduces to 0. Need reduces to 0, correct or not? Allocation will increase to 15K, correct or not? 15K. Now can I get the safe sequence which is available 6K? We can start with process B. Once process B, so once process B execution over, it will release what? 15K it will release, correct or not? So 15K plus 6K, so like 15 plus 6, so almost 21K is available. With this one I can see I can start like this, we can get this a safe sequence, I can get it. So therefore option C can be granted, option C can be granted. Option D, try option D. A request 6 kilowatts, A request for 6K. 6K if I given A, so remaining will be 6, and 6 nothing but remaining how many will be there? So 16K will be there, 16K here. With this 6, here is a 6 available, so I can satisfy process B, but I cannot satisfy, can we satisfy this one? 16K. Check it all of you, can I satisfy when a process A requests 6 kilo? Check for this one, check for this option D. Option C is true, option C is true. Check for option D also. So I repeat, if a process requested, I am just a few things I am removing here. So this 12 nothing but if I process if I remove 6K available, okay, need will reduce to 16K, allocation will increase to 9K. So this will be remaining same only, correct or not? So remaining same only will be there, 6K only will be there, 6K will be available. Now with this available 6 we can satisfy this one. It will release 15, we can only satisfy B only, it will release 15. So 15 it will release, correct or not? So meaning this will be how many? 6K means 6K I will grant, give it, it will release what? 15 it will release. So anyway this will be, again this will be 9K only will be available. So with this 15 you cannot grant C, we cannot grant A. So therefore I can say now option D also cannot be satisfied. Only option C, only option C can be seen. So therefore I can select what? Option C is the right one. Option C is the right one. Yes. I hope this is clear, all of you. Yes, yes. Move on to another question. Try this question, ma. Try this question. It is also good question. Try. All of you. I hope you got the answer for this question. Yes, Vinay, JP and Pardasarathi, try to respond. Yeah, okay. So what is the answer for this question? Did you try? Yeah, okay, thank you. So a system has 5 processes that require multiple instances of resources of the same type. Sum of maximum demand of all the processes are 38 given. at some point of time the system deadlocked and some of the need of the all the processes then was 14 with only one resource available. 14 was needed and one available resource available. The minimum number of resources that still required ensure that system will never deadlock is dash. Anybody tried? Yes. JP, Vinay, Parthasarathi. Anybody tried? N equal to 5 process we got. Sum of all demand of a process is how many? 38 given now. 38 are there. Now at some point in time the system deadlocked and some of the needs of the processes then was 14 need were there. Yes, yes. How many resources minimum required? Still required. Therefore now system will not deadlock. System will not deadlock. Some of the demands given. If you know that allocation, how many allocated? How many allocated? Right. Then you can find with the minimum how many required. You know the formula, correct? So minimum requirement what? So minimum requirement M is what? Sum of all demands. Sum of all demands of the process minus N plus 1, correct? With this one you can get M, minimum how many required, how many allocated is there, we can get it how many still required. So that deadlock will not happen, correct or not? This value need to find out, right? Yes or no? So M is greater than of sum of D value 38 given, correct? 38. 38 given, 38 given. So minus how many processes? 5 processes, 5 processes plus 1 now. So now M is going to be what? M value is going to be what? How much now? This 4 means 34, correct or not? 34. So minimum number of resource should have 34, 34 should be there, so that no deadlock will occur, correct or not? No deadlock will occur. Yes or no? This is only a requirement. This is only requirement, right? This is only requirement. 34 should be there, right? Correct or not? Now understand. Now see. We also know, like no example, you see allocation, how to get the allocation vector. Allocation, total allocation I am saying that. So maximum demand, correct or not? Maximum demand minus what? Allocation, I think maximum minus need, correct or not? Need. So maximum minus need now. So maximum demand is how many? 38. Okay, need, how many needs are there? 14 is there, correct or not? So how many allocated already? Already allocated. So what is the value we are getting now? 24 we are getting, correct or not? 24. Allocation is 24. Yes or no? 24 only. Now the one word they given here, one word they used. Okay. Deadlock the sum of the need of all the process that was 14 with only one resource available. One resource available, right? Available resource. Available is what? 1, correct or not? Allocation 24. Total how many available already? Total available, can you tell me now? Total available. Allocation, this 24 plus 1, 25, correct or not? 25 already there now. Now see, now my question to you, to meet the minimum requirement, how many extra, still I require some resources so that deadlock will not occur. So that I know, so what is the requirement? 34 compulsory will be there, right? 34 compulsory will be there, right? Yes or no? So the deadlock will not occur. So already available how many? 24, right? So therefore now still required, required resources equal to how many? So 20, this what you can say? This 34 minus 25. Is it not 9? Yes, how many people got 9? Very good, Parthasarathi. And JP also got 9. Vinay, check somewhere you did mistake, I think. That is the reason 6 you got. So 9 more required compulsory. Very good, very good, very good. Yes, yes, yes. It is. Isn't it known question? It is like question framed from known data only now. Correct? It is known area only, correct on. But you know, just carefully we should read and apply your known things only. What I know this one to solve, given number of process, total demands I know. So while reading this statement, how many minimum number of resources still required into the system, deadlock will not occur. So M must be greater than or equal to this formula we know. This we define. Total demand minus this one, correct or not? Very good, JP. Very good, JP, very good. See, my point, that's what, like, we believe in yourself first. Believe in your concepts. You believe in your concepts, apply it. It will come, it will come. So just aptitude question, right? M value we got, right? This M value we got. So definitely we can say deadlock will not occur with this M. Total demand, total requirement we got it. Now we need to know only available, how many allocated. This, since they given need, I can find the what need given, demand also given, I can find what allocation. So total allocation equal to maximum demand minus what need. So we got allocation value, right? And still available also, 1 copy also there. So therefore I can say 25 copies already there. We require 9 more copies, definitely I can ensure deadlock will not occur. I hope this is clear. But they can play aptitude questions on related to this requirement, minimum requirement of resources, causing deadlock, not causing deadlock, like this. Yes, ma. We'll see some more question. Ready for next question, all of you? Again attempt. I'll be giving 3 minutes time for this question. Attempt it. Attempt it. Sincerely attempt it. You will able to solve it. It is related to Banker's algorithm. Related to Banker's algorithm. You are able to solve it. Try. What is the smallest value of x for which the system should be safe? They are asking safe. What is the value I should take it so that it will be safe? So this vector will be here available. Just to modifying, you know, this need to shift maximum. This is allocation. Allocation. No, sorry, slightly, okay. This is the maximum demands. Now allocated is here, something missing. This is allocation vector. Allocation vector. This is allocation and maximum need. Maximum need, yes, available here, right? Yes, yes. Try this question. Yes, answer it. So this is the time you all need to emphasize on the like confusion area. Some areas seems to be understood, but still need to go through, go inside, understand and work out related problems, make yourself more comfortable in that area. So this way you need to dig into each aspect of the subject. And also all of you, I am strongly recommending, do not leave any topic, try to cover maximum topics, maximum important topics, because sometime easy question can come, sometime maybe tough question comes. If tough question may not be able to solve, suppose some areas easy questions comes, we are able to solve because we have only 65 questions, correct or not? So we do not have more questions to leave it. and also stay in the session, because so we are going to solve good questions from this memory management also. We will see some important topic how we can understand from memory management, we will observe it. Yes, and also during any practice, all dear my student, do not guess the questions, do not guess the answers. So we try all the way and try to maintain accuracy, much important, much important. So JP you are telling x equal to 1, so x equal to 1 you are able to solve. So now I need to find out the need vector, correct? Yes or no? Need vector I need to find out. So what is the need vector? 1 minus 1 0, so 1 minus 0 is 1, so 2 minus 2 0, so 1 minus 1 0, 3 minus 1 2, correct or not? For process B, 2 minus 2 0, 2 minus 0 2, 2 minus 1 1, 1 minus 1 0, 0 minus this 0 only. Now 2 minus 1 1, 1 minus 1 0, 3 minus 0 3, 1 minus 1 0 0. So 1 minus 1 0, 1 minus 1 0, 2 minus 1 1, 2 minus 1 1 1, need vector. So now this available vector is given, correct or not? Now so it is safe. To make it safe, what is the x value must be there, they are asking. Okay, sir, D nothing but no safe state. You are telling, Vinay is you are telling no safe state. No, what is the smallest value of x for which this is a safe state? So I need to make it a safe. What is the value I should choose? They given option A 1, option B 2 and 3. Let's try keeping x equal to 1 only. Let's try keeping x equal to 1. Therefore 0 0 1 1 will be there, right? So let's make it 0. This value is 1. Okay. So now what are the process I can satisfy? 0 0 1 1 nothing but can I satisfy? I am writing process D. So process D can I satisfy or not? So if I make it this this value, allocation I should add it, correct or not? Allocation if I add it 1 1. So this new value will get 1 1. So 2 2 1, correct? Correct? This value is right, all of you. 1 1 2 2 1. Because D well allocation, like what you can say, sorry, available, sorry, I think I wrongly did. Okay, available is what? 0 1 1 is there, available plus allocation I have to do it, right? So this value is 1 1. So this third one is already 1 is a 2, fourth one is correct only, right, 1 1 2 2, right. Now with this 1 1 2 2 1, which process you can satisfy? Can I satisfy this process B? Process B second 2 copies required, we cannot do. Process this also cannot do it. So I cannot satisfy any one of them, correct? For x equal to 1, we cannot satisfy any one of them. Am I right, all of you? So why, sir? Why it is not able to do it? Because this x, this is the second one required 2 copies. So this required 3 copies required. This required 2 copies I do not have, correct or not? So therefore can I stop x equal to 1? Not possible. Can you try for x equal to 2? All of you, can you try for x equal to 2? Will I able to get the safe sequence? X equal to 2. Yes, JP. Suppose if I take x equal to 2, this value is 2 if I take it. Now with this 0 0 2 2 1 1, I can try D first only. So D, then what happens? Allocation I should add it. 2 plus 1, this becomes third one becomes 3. So 1 1 3 2 1, 1 1 3 2 1 nothing but I may able to satisfy with this process C. C I can satisfy. If I satisfy C, so C value I should add it. So this becomes 2 2, this is 3, 1 becomes 2 2 3 1 becomes which process I can satisfy? C, D over C over. So I can satisfy even this B also I can satisfy. So B means what I have to add, this becomes 4, this becomes 2, this becomes 4, 4 B allocation only added 0, correct? 0. Need vector is correct. So 3 minus 1, 2 only. Sir, I did silly mistake again. Sir, B is true, x equal to 2, correct? Are you sure x equal to 2, correct? Everyone? Yes, respond, everyone respond. For x equal to 2, is it possible? Did you check JP and Vinay and Pardasarathi? So this D, process D, when I add it 1, this if I add it this allocation value will be 1 only, 1 only. Is it possible? X equal to is possible? Vinay? 42440, but it required 2 copies. I don't have 2 copies, right? This has 1 copy. That's what I am asking, right? Is it possible to process it? Because we need 2 copies, I do have only 1 copy, correct or not? Yes, yes, JP and Vinay, try to respond. Carefully, step by step, clearly try to work out. So we have started with the D only because 00211. So 00211 means, so need I have to observe, only D is possible, D I started. So when D means allocation vector I have to add. So you can calculate, right? 0, 1 minus 1 0, 1 minus 1 0, 2 minus 1 1 1, 1 correct only. 1110 if I add it. So this becomes 11321 came. So with this one 11321, 11321 nothing but I can able to satisfy process C because 10300. So 10300, yes. Then process C 11011 I am adding, 11 is 22, this became 3 only, this became 3 and 1 is there. So the 22331 nothing but I can, so 02, this is possible, B I can satisfy. So B allocation vector when added this becomes 4244, 1 only it became. So this exactly the value is correct, right? Yes or no? So with this one, this you are not able to satisfy, correct or not? Therefore we are not getting the safe sequence, right? So no safe sequence, yes. Option D is right. Yes, yes, yes. Option D is right, ma'am. We have to be careful. See, 2 mark question, which we know sometimes we do the mistakes. We have to do carefully. For any question when you are attempting, we have to be consciously, you have to read consciously, you have to observe step by step properly you do it. Do not lose, suppose silly mistakes if you do, you lose the marks because we don't have more questions. So every question is important for us. So I hope this thing is clear. Okay. So now we will move to memory management. So one more thing, so few things if I would like to add from deadlock point of view. Also try to cover the deadlock detection recovery part is there, detection mechanism we have now. Wait for graph, again Banker's algorithm we can use to multiple instances get detecting, that we know. So these are the things we covered it, and just revise this some, what you can say, work out more PYQs on banker related problems, Banker's algorithm related problem. So that is sufficient, that is sufficient. Now most important and very crucial topic from operating system is what? Memory management. Okay. Here we will see the memory management, various techniques we will observe. So memory management, so various memory management techniques we see. Okay, techniques. So techniques nothing but memory allocation methods only. Okay. So broadly this mechanisms we have. One is contiguous allocation, correct? Yes or no, all of you? Contiguous allocation method. Contiguous allocation method. The second one is the non-contiguous allocation method. Non-contiguous allocation method. So non-contiguous allocation methods we have, right? So non-contiguous allocation methods we have, right? Yes or no, all of you? So now under contiguous allocation, if you see the first area, look at contiguous allocation methods. Contiguous means what? What is the meaning of contiguous here? Contiguous nothing but program is what? Program is loaded. So program is at what? One place only. One place, correct? That is the meaning of contiguous. One place only. This we also called centralized. Centralized mechanism also we can tell. Centralized mechanism also we can tell now. So we use a mechanism called first one is what? Partition, right? So partition mechanism we use it, right? Partition. So partition mechanism of our two types, right? One is a fixed partition, right? Fixed partition. Fixed partition. Then second one is what? Variable partition. So variable partition. Variable partition. There is also mechanism we have buddy system also there here. So buddy system. So this also contiguous memory allocation method only now. Okay. So these are the mechanism can be seen. Okay. So just observing the in terms of performances we'll see. Suppose first thing is I am observing fixed point. So fixed partition mechanism, if I say fixed partition mechanism, followed by second one is what? Variable partition mechanism. Variable partition mechanism. Variable partition mechanism. Some points we can observe. So this will help us to analyze these algorithms here. Okay. In this case, a number of partitions are, tell me, number of partitions. Okay, number of partitions are fixed, correct? Are fixed. Here is what? So now you understand partitions are, here partitions are variable length and number. Variable length and number. Here is what? Number of partitions are fixed. Partitions can be what? Variable size. Partitions sizes can be variable, please understand. Partition sizes can be variable here, but number of partitions are fixed. Here number of partition size what? Variable. That we know, correct or not? So this is also called multi-programmed with a fixed number of tasks we can call. So this also called multi-programmed with a variable number of tasks also we can call. Yes or no? Am I right, all of you? The statement is right. Now my question to you, some points related to this one. So we know operating system, how this will ensure the protection, right? So we have a starting limit registers, we have lower and upper bound that will maintain. The address generated process must be lower to upper. So then we can say allow to access, otherwise we can trap it, correct or not? That is the process we do it. Now does it suffer from internal fragmentation? Tell me, all of you. So here also, does it suffer from internal fragmentation? Tell me now. Yes. Is it suffer from internal fragmentation? Everyone try to respond. So does fixed partition suffers from internal fragmentation? Fixed partition suffer from internal fragmentation. I am marking as yes like this, yes. So does it suffers from internal fragmentation? Variable partition, answer is no. Some people might have doubt. Now see, does it suffer from external fragmentation? So does it suffer from external fragmentation? Tell me. external fragmentation is there. So Vinay, JP, Pardasarathi. Does fixed partition suffer from external fragmentation? So this won't suffer from external fragmentation. This suffers from what? External fragmentation. You understand? You understand? Try to understand this one. Very good, very good. So it won't suffer from external fragmentation. Why? Because partitions are not made. Fixed not suffer from external fragmentation, but variable suffer from. Very good. Very good observation. Very good observation. Very good observation. Okay. So now we use allocation policies, right? We use allocation policies. So which policy performs better in this case? So best fit policy. You might have studied best fit allocation policy, correct or not? So here is a allocation policy. Allocation policy, it is used what? Worst fit. Worst fit performs better here. So worst fit performs better here. So in terms of space we are taking, in terms of memory space, best fit allocation policy better for what you can say fixed partition. Here is what? Worst fit, because largest partition always choose to allocate the process, because after that also will create a partition that's bigger than the if you select any partition. Very good observation. Now degree of multi-program restricted here, correct or not? Here degree of multi-programming is flexible, we can increase the number of processes, correct or not? Variable partition, degree of multi-program. Now here you understand program size, what is the maximum program size can be designed in case of fixed partition? So respect to the partition size only. Here is what? Main memory size, that's what so increasing the program size flexible in this case. Variable partition, it is not flexible, restricted to what? Particular partition only. But both are outdated mechanisms only, correct? In modern operating system, no mechanism being used. In practice, if you take Windows or Linux or any operating system, if you take modern, so these two mechanisms not at all used. Initially some Windows operatings are used, variable partition initially used, not now. So I hope these things are clear. But to solve this external fragmentation, so we are moving, please understand, we are moving the second mechanism is what? Second mechanism, non-contiguous allocation. So non-contiguous allocation methods. Am I right or not, all of you? To solve the problem of external fragmentation, because variable partition solve the internal fragmentation. It is suffer from the external fragmentation. Theoretical question bound to come in this area. Theoretical question bound to come. One more questions. Okay. So non-contiguous allocation. So we have mechanisms called, like one is a simple paging. So simple paging mechanism we have. Simple paging. So now second is a segmentation concept. Segmentation. Third one is to understand segmented paging. Combination of the segmentation and the paging. Segmented paging we can say. It is a combination of both the above methods. The fourth one is a inverted paging. Opposite to paging, this is inverted paging. We are mapping to physical memory. The fifth one is hashed page tables also can be used. Hashed paging also we can say. Paging. Like various mechanisms are there, like so most important thing simple paging. Simple paging very much important for gate. Segmentation also one or two times asked some related. So never seems like segmented paging, but we've seen inverted paging related also sometime questions, theoretical questions asked it. And these topics are much important in case of non-contiguous memory allocation. Every year you can see the question from this simple paging. Sir, simple paging, segmentation, multi-level paging, inverted paging, segmented paging, hashed paging. Multi-level paging is a solution to what? This problem only. Some problems which are facing simple paging, the solutions is a multi-level paging. One of the solutions is multi-level paging now. It is part of the paging only, okay. So now when you look for this general architecture of this paging is what? A process which is running in a CPU, okay, generates address. So this address we call logical address, or we can call virtual address. We can call even effective address also we can call. Effective address also we can call, correct or not? This need to be translated into what? Physical address or actual address where you can see main memory, like this pointing to main memory, please understand. It is pointing to what? Main memory, through which you can see this main memory now. Some person I should keep it to translate this one. This person is nothing but memory management unit, please understand like this. Translate from logical to physical address. If I implement by paging, so page table I'll use. If I implement by segmentation, segment table. Both the combination, so both tables required, page table, segment table, both required to translate from logical to physical address. Now you should be very careful, you should understand what is a logical address. Somebody tell me, what is a logical address? What is a logical address refers? Tell me. You should understand meaning of this logical address clearly. Everyone. Vinay, are you there? So what is meant by logical address? What is meant by logical address? Yes, respond. Logical address, or also refer virtual address or effective address also we can say. Effective. Sir, address generated by CPU is a logical address. Yes, you are right, address generated by CPU. So to get little clarity over this one, so what is generating, what is generated of this logical address by the processor? Okay, if you take this a main memory, okay, please understand now. Somewhere a program loaded, suppose assumption, some program loaded, program instructions are loaded in an area, suppose example like this. Maybe program size is what 100 bytes assumption, 100 bytes are there. And maybe starting address is, let's take 500 onwards loaded. In a decimal address 500 I have written, 500 written, okay. Carefully listen ma, what is this 500 here? Now program size, what is the program size? So program size is 100 bytes, nothing but 0 byte, 1 byte, 2 byte, 3rd byte, like this, 99, correct or not? So these are the program area. So this also area. Can I say this also logical address space or virtual address space or program address space? Can I tell? Program address space also can I tell? Virtual address space, logical address space, program address space, can we tell or not? Which is always, you understand, we given to the illusion to the processor or programmer, your address start from always 0 to is your maximum size. So therefore now this process PI when is running in a CPU, so now address of a instruction or a data defined in a program counter, correct or not? Come take the picture of the CO here, correct or not? Address of instruction to be executed that kept in a program counter, take a program counter value, it is refer it. Try to recall the diagrammatic view of the fetching of instruction, fetch instruction. So take a program counter value, visit the memory, right? That means program counter value placing on address bus. Placing on address bus is nothing but generating the address. Logical address is nothing but, please understand, is a respect to the main my program address. So I am giving a reference to memory, It is completely independent to current assignment of the program in a memory. It is not program where present. We do not know the where program is present. It is reference to, please understand. Logical address a reference to main memory, please understand. Reference to main memory. It is completely independent of the current assignment, current present of the memory, what program in a memory, and need to be translated from logical to physical address with help of some component that is called memory management unit. So now you understand, suppose first byte I want to accept. So now logical address generated what? 0 only. Logical address generated 0. Suppose this logical address going to main memory like this, going to memory. Now my question to all of you, 0 address is say CPU telling go to this address, you will get a program instruction, first instruction data you will get it. If go to 0. If I go to 0, can I get it? Respond everyone. If I go to the 0 location, can I get it here? No. It is somewhere present, correct or not? But 0 is a reference to memory. My program memory also started. Some 0 address onwards or not? 0 address onwards program started, the memory started, right? If you go to 0, something is present, but it is not your program. Your program is placed from what? 500. So therefore, what should I do? Some person has to translate this address into what? 500. So 500. Therefore, I am going to 500. I can access my data. Now exactly, so I can give one example to understand this one, why we have to do it this one. One simple question I will ask. You are going to write the GATE exam on 1st February 2025, correct or not? 10 days prior you will be getting the admit card, correct? Yes or no, all of you? Admit card. In this admit card, address, the center address will be there, correct or not? Yes, yes. Now your exam center address will be there in this one. So in that admit card, just tell me, will they mention like which college you are going to write, and in that college which block, which department, which floor, which room number, which seat number, will they write? Will they write in this admit card, so that you know exactly where you are going to sit in that particular center on an exam day? So they won't write. Do you know what is the reason behind that? Why they are not writing exactly where you are going to sit writing an exam? Yes, yes. Some of you, please answer it. It is exactly the same thing happen here. We can correlate to this concept. The role of translation come into picture. They are not writing. Reason why they are not writing in that. So do you think that address sizes will increase? No. Maybe one line more increases. Already 1 or 2 lines address comes. If I write it, one more line increase. I can increase A4 big size only, correct or not? It's not matter of where you like increasing address size. So what is the reason? So they are not writing. The reason you understand, that which you know already, because if I specify where you are going to sit it, if that particular lab or the particular room, suppose dynamically some problem created, they are not able to shift it, correct or not? They cannot change 5 days back before the exam, saying that no, your address is changed. So they cannot update your admit card, correct or not? So that is a dynamically sometimes they may shift the entire block to block A to block B also. One lab to other lab also they can shift it, correct or not? So therefore only they are writing, right, reference given to you, correct or not? It is only reference where you are going to write a GATE exam, correct or not? On exam day only, on exam day when you reach 30 minutes before, outside the gate there is a one mapping table will be there, right? So and so rule number onwards here. So go to block number A, block number B, block number C. After reaching block number A, again they are writing lab number something, correct or not? After reaching lab number, you say that somebody will guide to sit where you are going to take the computer, correct? Yes or no? On run time only you are able to get your exact address or not? The same thing story, understand. If I promise to CPU, where program is present here, if I promise it to CPU, what happens, you know? What happens? So we are dealing with a multi-programming operating system, right? My main memory can occupy with a many number of processes. Whenever sometime other processes operating system want to take it, if memory is not sufficient, process can be suspended to secondary memory. When you suspended, when you resume it, the process may not get it exactly where it was loaded, correct or not? If I promise address to CPU, each time process when shifted to secondary memory have to change all the registers here, what address you know already, correct or not? It going to be problem or not? So that is where simply we are telling, no, you do not bother. We are telling to the processor, you do not bother where I am loading here. I have loaded from 0 to 99 only your program. Always you fix in a mind. You are fixing a mind, your address of a program in a main memory can be seen from 0 to 99. That depends on the program size. Sir, program size 1 KB is there, 0 to 1023. Programs are 10 KB, sir, 0 to 10K minus 1. These are your addresses only, logical addresses. Logical address space, nothing but what? Collection of the logical addresses only, correct or not? So logical addresses which you generate, your address start from 0 to its maximum size. You generate. So we are creating illusion to you. Yes, I know where exactly your program is present only, but it can be placed anywhere, correct or not? If I place it anywhere, so no need to promise to process where program is present. Dynamically runtime only we are getting. So you have to maintain some mapping table, that is through what? Page table or segment table. You are able to translate 0 to what? 500. I don't know what hangama you do it. You should replace, you should convert 0 to 500. So 500, my data is there. So next address is 501, next is 502, like this 599. Your program is 500 to 599. Sir, after some time shifted to 200 onwards, sir, 2000 onwards, sir. So you have to translate 0 to what? 2000. Clear? 0 to 2000. Sir, sometimes started loaded from 0 onwards, sir. Yes, 0 to 0 map it. So this required, please understand, under multi-programming environment, address translation mandatory. It is a mandatory functionality in case of multi-programming environment. If it is a uni-program, does not require, because only one program will load into main memory will run, correct or not? Yes or no? Yes, Vinay? So I hope it is clear the role of logical address. So logical address reference to memory, not exactly the memory location. Reference to memory, it is independent of where program is present. Translation must be needed. So what is the physical address? Physical address, exactly, absolutely original where program is present in a main memory now. Yes, I hope this is clear now. Okay. So under simple paging, what we'll do? So page table, right? We use a page table to translate, correct or not? So you know implementation structure, right? So let me go directly to performances. Do you know the implementation of simple paging? Taking logical address split out into what? Page number offset. Page number you search into page table and access the frame number. Frame number you add to offset value, then translate and get your frame main memory, then get the data of the frame. Is it, this is clear, right, all of you? This is clear, right? Very good, very good, very good. Come to the point. Okay. So I hope it is clear. Terms are clear. Logical address space, physical address. So always you understand, if I know logical address something 13-bit, okay. So the set of logical addresses nothing but logical address space only, that is 2 power of logical address. So this 2 power logical address 13 nothing but 8K, 8KB we will get. Similarly, if I know physical address, so I can get the physical address space equal to 2 power of physical address, correct or not? So unit I am taking as a byte, here also byte like this. So this we know, correct? These are the things we know clearly. Okay. So you know, right, how to find the number of pages in a logical address, how to find the number of frames in main memory. So now what is the difference between page and frames? In simple paging, what do you do? Entire program address space we divide into equals as pages. Main memory also we made into equals as frames. Page of a process we are loading into frames, correct or not? Page of a process loading into frames, then we will run it, correct? Simple paging, if I want to run n pages of a process, I need n empty frames here. I load this n pages in empty frames, we will run it, correct? This scenario is clear, everyone? Under simple paging. Very good, very good. So now when it comes to performance of the simple paging, if you see performance of simple paging, if you see, there are two aspects we need to understand. One is temporal issues or aspects you can say. The second one is spatial, memory space, spatial issues. This is for a time, access time. This is for what? Space, you understand now. You know that where page tables are loaded? Where page table is loaded? Page tables are processed where they are loaded? All of you. Page tables of a process where they loaded? Main memory only, correct or not? If I created 200 processes, so 200 page tables are kept in a main memory. That's what you treat like, suppose 100 examination centers are there. In 100 examination centers, each center at outside the entry gate there is a table will be there, right? This mandatory table to translate your address. Your address is nothing but now your all ticket numbers, all you understand now. Logical address is given, you have to map to physical addresses where you exactly are going to set it. Same thing can happen here also, correct? So 200 process created in the operating system, nothing but 200 page tables are there. So who is creating this page table? Page table also known to be memory management unit, correct? Memory management unit or page translation table or simply page table or process object also we can understand. So process object PCB. So page table we can tell, okay. This is created by operating system only, is duty to translate logical to physical addresses. This information we know. So coming into this temporal issues. So coming into the temporal issues, please understand now, the first aspect if you see temporal issues. So temporal issues, understand now time. Generally main memory access time is what, let's take m unit, and effective memory access time is going to be double, 2m happening, correct? Am I right or not? Respond. 2m is happening, right? Reason sir, 1m is to access the page table, then after getting physical address you have to access the frame also, right? Frame of a process also should access, therefore 2m required, right? So to reduce this 2m to 1m, so 1m I have to reduce, we have to use what? Translation look aside buffer, correct or not? Translation look aside buffer. What is the translation look aside buffer? Can you tell me? What is this TLB? It is basically, it can be a cache memory, please understand. It can be a cache memory, or maybe one more can also associative memory also we can tell. Associative memory also we can tell this one. It can be implemented by associative memory also. Associative memory is the fastest memory, please understand. It is among all memories very fastest, even faster than the faster than the cache memory. Fastest memory we can say. It is little expensive, either you cache or associative, but so you can tell me now why can't call cache memory only, why we are calling translation look aside buffer, why it is named as TLB? The reason very simple, cache when I say it has instruction data both will be there, but TLB do not containing any instruction data of a program, it is only maintains what? Entries in which page number and what? Frame number will be there. Page number of a process, process ID, page number, corresponding frame numbers will be this entries. That's what translating data only we have, translation from logical to physical information we will have. So that is the reason we call translation look aside buffer, but otherwise we can say physically this is also cache memory only, or maybe implemented by with associative memory also can be observed, right? So what is the expression, can you tell me with this respect? So effective memory access time, effective memory access time if I see, x is a TLB iterate, access time of the TLB if I take C, so now x into C plus will happen, whenever the TLB miss occur, so C plus 2m will happen, m plus m will happen, correct? This only expression, all of you. With TLB plus memory access if you see, so first we will try to search in TLB to get the page number and frame number. If we get a physical address, I will access directly from memory, 1m I can get it. That's what, whenever iteration of the TLB very high, you are getting 1m only, right? Why? Because C is what? C is much smaller than m, right? So this value is small, that is the reason we are telling m only will get. Very good, C plus m, right? When miss occur, I have to go to page table should access 1m, then already overhead of C will be there, other m is required. Now tell me, how much is the overhead here? What are the overhead elements here due to TLB introduction, due to page table introduction? Can you tell me? What are the overhead elements or units because of introducing the TLB, because of introducing what? Page table. Some of you, tell me. Yes, yes. So if TLB, if page table is not present, main memory access time only 1m will be there, right? Yes or no? Only 1m will be there, right? Normally 1m can be seen. But TLB compulsory C is required or not? C is the overhead when TLB hit. When TLB miss, so C plus m is the overhead, please understand. Two component, when TLB miss occur, normally 1m only, but extra this two happen. Am I right? This also we can say overhead expression of effective memory access. Even further can be optimized by adding physical address to cache memory, or virtual physical address to cache memory, or virtual index to cache memory. By adding this one, we can optimize this one. So that way we can temporal issues can be resolved. Temporal issues can be resolved. Other is the second one is the spatial issues. So spatial issues. Spatial issues. Here two aspects we need to understand. One is the page table overhead. Page table overhead, page table size overhead. Okay. The second one is the internal fragmentation will have, correct or not? Internal fragmentation. Am I right, all of you? Does paging is suffer from internal fragmentation or not? Does paging is suffers from internal fragmentation or not? JP is not 2 times of C plus M. Acha, 2C, correct only, total, right, you are right. Here is 1C, here is 1C plus M, yes, 2C plus M, right. So now it suffers from internal fragmentation also, correct? Yes or no? Now ultimately we need to reduce this one, right? What are the solutions we have? One solution is finding the optimal page size. One solution is we are finding the optimal page size, correct? So what is the optimal page size? P equal to square root of 2 times of SE, correct? This is only optimal page size, where P is a page size and S is a logical address space and E is a page table entry. Yes, yes, from internal fragmentation of the last page of a process. Very good observation. Internal fragmentation will not happen for every page of a process. It only happen last page of a process. It can happen. It may happen. Please, it may happen. Last page of a process. Very good. So second solution is what? Multi-level paging. Second solution is what? Multi-level paging. Correct? So this is solution to the what? Spatial issues. Solution to the spatial issues. Suppose if I take multi-level paging, let's take example. Logical address is what? 32 bits. Considering page size for a process, let's take 4 KB. Let also take page size, okay, 1 KB for page table. Page table address I have to do it. Multi-level paging means what? Paging on page table. Paging on page table, because single page table size is very high. To reduce this one, we are applying what? Multi-level pagings. Now if I take this process, suppose running in a CPU, whatever generated address we call logical address, okay. If the logical address is 32 bit, so first level paging and offset value D I am representing, 4 KB nothing but 12 bits required, here 20 bits required, correct? Paging on page table is very good, multi-level paging. Now how many entries I will get as per this one single level page table? If you see, 2 power 20 entries will come. Further I am doing the multi-level paging. The page size I have taken 1 KB. So further I can do it like this. So now this P1 I am writing, this is a D1, offset value depends on the size. So 10 bits will go. Here is a 10 bits, right? This will point to outer page table. This will point what? Outer page table, please understand. Now number of entries depends on this value only. Number of entries in outer page table depends on this one only, correct or not? So 0, 1, 2, 3 like this, 1023 entries will be there now, correct or not? It has a inner, so what this outer page table contains? Outer page table contains frame number of a memory in which inner page table or page of a page table is present. So if I take this address, if you go to this frame number, you will be getting inner page table, okay, inner page table. So number of entries in inner page table defined by, so this offset value. So here also entries 0, 1, 2, 3, 1023 will be there as per this data. It is actually contain the frame number. You have to take this frame number bits, pad this original D value. So this becomes a physical address. So we can access the physical address space, correct? This we call multi-level paging. As per this data, can you tell me how many inner page tables are present? outer page table contain the starting address of the inner page table present memory. So that is right, absolutely right, that a starting address is nothing but frame number only, correct or not? Because all inner page tables, outer page table, pages of a program, all are loaded into main memory frames only now. Yes or no, everyone? JP, Pardasarathy, Vinay, either you take outer page table or inner page tables, pages of a program, all are loaded into what? Frames of main memory only, correct or not? That's what. So this address, frame number only, in which inner page table is present. This is a frame number only, in which page of a process is present. You should understand this way. Very good, 1024 inner page tables are there, outer page table 1. So total number of page tables are 1025. 1025, correct? 1025 page tables are there. Sir, how it will reduce? So we take the support of virtual memory. All inner page tables we are trying to keep it to secondary memory. We keep it secondary memory. So whichever page of a process required, that particular page of a page table will load into main memory, then we can access. Always my outer page table should be present in what? Main memory or not? Always outer page table should be present in main memory, through which I can access inner page table, through which we can access page of a process. Am I right, all of you? Yes, we implement demand paging. So with the support of demand paging, we can do it. Okay. Suppose my question to all of you, now this is a program. What is the program size possible as per this example? What is the program size possible as per this example? Program size. Four GB application, 4 GB program, correct? Respond. 4 GB, very good. So 4 GB program, suppose I loaded it entirely into main memory, assume 4 GB loaded, 4 GB program is loaded here, loaded, assume it. Now how many minimum number of page tables should be there so that no page fault occur? Every page, every reference going to be it. How many minimum number of page tables I should keep it main memory to execute this process size of 4 GB without page fault? Without page fault. Answer it. Yes, answer it. My question is clear. Let's take program size or application size 4 GB as you mentioned. So 4 GB program loaded, fully loaded into main memory. How many minimum page tables I should have so that without page fault I can, every virtual address can be translated. Every virtual address can be translated. Answer it. Very much important. I am asking number of page tables. 2 power 20 are pages of a process, correct or not? 2 power 20 is the pages of a process. Not 2 million. Not 2 million. Yes, JP, Vinay. Not getting question. Suppose I repeat my statement. By looking at 32-bit, we can tell now total program size, virtual address space. Virtual address space nothing but program only, right? Process size only, right? Correct? Confirm me. JP, program size is what? 4 GB, 2 power of 32 logical address, 4 GB program size or virtual address space or logical address space or process size, right? This is fully loaded into main memory, fully loaded, fully loaded. Now, how many minimum number of page tables should be there in the memory so that every virtual address can be successfully translated without miss? Sometimes page of a process not there, we call a page fault. Without page fault, I want to run it this program. How many minimum number of page tables should be there? Entire program. Answer is there, here only answer is there. No need to much think also. Isn't it 1025? So, 2 power 20 frames occupied my program, because one page size this much, 2 power 20 frames occupied. All must be present on one outer page table, all inner table should be there. Make sense? Yes, Vinay, correct. Vinay, correct. 1025. 1024 inner page table. Just now you told, sir, 1024 inner page tables are there. One is outer. All must be there so that every reference generated can I able to translate successfully without page fault. Yes, Pardasarathi, did you get? JP. Yes, 1025. Now, how many maximum page tables I should have so that I can translate again successfully? Maximum number of page tables. Minimum 1025, maximum how many should be there? Maximum page tables I should have so that every reference can be translated without page fault. Isn't it again 1025 only? I don't have more, right? Already I kept everything. Minimum itself 1025, nothing. Maximum also should be what, 1025 only. Do I have more than these page tables? Internal, inner page tables are 1024, one is outer. Again 1025 only. Clear? Question and answer is clear? Yes, yes, yes. Everyone. JP. Now ready for third question. Suppose one outer page table is only one inner page table is there. One outer, one inner is there. Only one inner page table. One inner page table is there. Only one inner page table. Now how many virtual addresses, how many distinct virtual addresses successfully can be translated without page fault? I repeat my statement. So I repeat my statement. Okay. So one outer page table present and one inner page table is there. Inner page table is there. One outer, one inner. Okay. What is the question? How many distinct virtual addresses can be translated? How many? So maximum on it, or simply you can write distinct itself will give unique things. How many distinct virtual addresses can be translated into physical addresses? So without page fault. Answer it. So required understanding, you should be focused little you need to be focused properly, then you can answer it. It is not 1024, not 1024. Virtual addresses, I repeat, virtual addresses. How many virtual addresses can be successfully translated with this having a one outer, one internal, one inner page? This can be futuristic question. They asked with respect to TLB, but through PS table they did not ask. Can be expected, not next year, but any year can be expected. It is possible question in future. Is a potential question to frame it. Yes, think. 4 million. So one entry, we have 1024 entries. So you are going to refer 1024 frames. Each frame is 2 power 10, 2 power of 12, 22, 4. Vinay 1 million. GP telling 4 million. Pardasarathi. So now one thing you understand, easily we can answer it. So we are not looking how many entries are. One valid entry must be there, so that in one inner page table you can access it, correct? One inner page table, how many entries are there? So I am saying fully loaded this one, this is loaded, fully inner page table is there. So how many entries are there? 1024 entries. 1024 entries, nothing but it is referring to 1024 distinct frames in main memory or not? Am I right? Each frame number, correct or not? Entries do not have duplicate frame numbers, right? 1024 frames you are referring, correct? 1024 frames you are referring, correct or not? So 1024 frames you are referring, correct or not? In each frame, how many bytes are there? Each frame, how many bytes are there? Is it not 4 KB? It is not 4 KB? Hello? For my 4 kilobytes are there, nothing but always logical address comes 1 byte addressing to 1 byte, 1 word, or 1 page you want to know, you want to take it. Suppose example, so logical address generated. This reference to fetch 1 word or 1 byte or entire page I want to read it. Tell me. What is the logical address given? Logical address given to refer either 1 byte or 1 word, correct? Either 1 byte or 1 word, not entire page. Entire page CPU will not take at all. Correct? So now one frame, once you point one frame you pointed, distinct 4096 addresses can be seen or not. Getting my point? This value, this 4K, nothing but 1024 into 2 power of 12. 2 power of 12 distinct physical addresses can seen or not? Hello? Correct? So therefore this value is almost 2 power of 10 into 2 power of 12. This is 2 power of 22. 2 power of 20. 4 million addresses can be seen. Somebody given answer, very good. Somebody who is given this answer, 4 million JP. Excellent. Yes, 4 million addresses. 4 million virtual addresses can be seen. Successfully, correct or not? 4 million. Out of 4G, 4 giga references, this is successful. Because we have one. If 2 tables are there, 4 plus 4, correct, 8, like this will go, correct or not? Question is clear, answer is clear, everyone. Anybody having a doubt so that I can explain? Answer is clear. 4 million virtual addresses successfully I can translate into physical. So one more question I would like to frame it. So as per this only. Are you ready, ma? One more question. What is the maximum size process size can possible here in this architecture? In this architecture, what is the maximum size of the process possible? Respond. What is the maximum process size possible in this architecture? Where we need this kind of things need to be observed, so that if you have a clarity now, any new type of question comes, you are able to understand the question. What is the challenge? If you understood question, you understood, I think 99% solution already done. So 1% only just doing the work. Understanding question is very much important in a gate. What is the maximum processes possible in this architecture? 4 GB. Just now before you answered 4 GB, correct or not? Now my question to all of you, suppose process size is 2 GB is there. Process size what? 2 GB. Process size is 2 GB. Now suppose process size 2 GB fully loaded. Now how many minimum number of page tables required? Can you answer? So can you answer, all of you? Can you answer the question? So I am taking process size is 2 GB. Okay, as per the above architecture only. Okay, and loaded. So loaded into main memory. It is loaded. Now question is that how many minimum number of page tables required to run this process? Yes. Question is clear, all of you? Question is clear? So now process size. So I must know how many frames I need to access, correct or not? How many frames I need to access? So number of pages required for a process equal to process size 2 GB by page size. What is the page size we have taken? 4 KB, correct? As per the example, 4 KB. So this value 2 power of 31 by 2 power of 12 bytes I can write it. So this value is how much? 2 power of 19. Is it 19 only? So 19 nothing but 512 K. So 512K what pages required? 512K pages required. 512K pages or not? So therefore 512 frames I should find, correct? 512 frames I need to find out. 512 frames I need to find out. So 512K frames I need to find out. KB won't be there, ma. So frames, number of frames required. So number of frames required is what? 512K required now. So now 512K entries I have to keep it, correct or not? 512K entries I have to keep it in inner page tables, right? So now I am writing number of inner page tables. Inner page tables, how many required? So 512K by one inner page table, how many entries will be there? In inner page table, as per that, how many entries we have? Is it not 1024? So therefore 512 internal inner page tables required. All of it clear? Inner page table what? How many required? 512. So now number of outer page tables, how many? Only one. Therefore number of page tables equal to 512 plus 1, 513. Total 513 or not? Minimum required how many? 513. Very good JP, very good. Total 513. Maximum how many required for to run this program only? To run this program, maximum how many required? Full 1025, because randomly might be placed, right? Maximum if I ask, all required. Minimum this many required. Like this you can able to solve the questions. Chalo, we will see the questions related to when I maximum required, total 1025 required. We'll see some questions related to this one. Can you answer this question, ma? Quickly answer it. Quickly answer it. Okay. So, am I audible clearly now? So, try this question. Try this question. So, before question was simply, this offset value 12 bits will be there. First level, second level, offset value will be there. 12 bits nothing but 4 KB I can do it. 4 KB I can do it. Correct or not? Try this question. Yes, try to answer the question. Answerable question. Virtual address space supported by 2 power of 64 bits. The page size is 1 KB. The size of the physical memory is what, 64 kilobytes. Size of the page table entry 2 bytes given, and address at the byte level. Then size of the standard and inverted page table. Standard page table size is equal to number of entries are into E. N is the number of pages. So number of pages nothing but 2 power of 64 unit is byte divided by, this must be bytes. Okay, bytes. Page size is what, 2 power of 10 bytes. So this value is 254, correct? Now entry size is what, 2 bytes is there, right? This value. This nothing but 2 power of 55 bytes I can write. Standard page table, 2 power of 55, only option B is matching. So inverted page table size is respect to what? M into entry size E. M is the number of frames. So number of frames, how to calculate? So 64 KB by 1 kilo, KB cancel 64 into 2 bytes, 128 bytes. So you are getting 128 bytes. So therefore I can say, so 2 for 55, 128 bytes. Yes, right. Oh, so most of you right only. Look for this question. Tell me which of the following statement is or false regarding page fault. Page fault occur when two pages of two different processes map to the same frame in a memory. Is it a page fault? Which of the following statement is or false regarding the page fault? Option A is correct. Option A is correct. Page fault, please understand, page fault is a reference, please, valid reference. It is not invalid. Valid reference to a non-existing page of a process. It is a reference to a page which is not brought into main memory, correct or not? A reference to a page of a process which is not brought into main memory is called page fault, correct? Is a valid existing, non-existing page of a process. So therefore this option is, this is false, correct or not? Page fault occur when a process reference a virtual page of another process. It is talking about not another process. Page fault given reference to a page of my process only, but that page is not brought into main memory, correct or not? This also false or not? False. When a page fault occurs, segmentation fault is generated. Is it true? Is it true? When a page fault occurs, segmentation fault is generated. Again, segmentation fault, when you generate, if you are trying to access other segment data, correct or not? You are trying to access other segment, correct or not? This also false, correct or not? Increasing the page frames may increase the number of page faults. Is it true or false? Statement D is true or false? Statement D is true or false? Tell me. Statement D, option D is true or false? Read, increasing the frames to a process may increase the number of page fault. Yes, Belloti's anomaly. The statement is what? True only. Yes, JP, true or not? True. So therefore option A, B, C are the answer for this question. Answer A, B, C are answer for this question. Now, a virtual memory has a page of 1 kilowords. There are 8 pages and 4 blocks are there. Associated memory page table contain the following entries. So page number followed block number. Block number is nothing but frame number only, ma'am. Frame number only. Okay, just take this structure, take the screenshot so that I can show next one. Yes, Vinay, you are right. Noted? Just take this one. Page number 0 present frame number 3. Page number 2 present frame number 1. Page number 5 present 2. Page number 7 present 6. Like this given. Yes. Yes ma, yes ma. Noted? Now see, which of the following virtual addresses in decimal will not cause any page fault if reference given by the CPU? Which of the following logical addresses will not cause page fault? Page fault. Yes, yes, answer it ma. Try yourself, you try. I am giving you 2 minutes time. Let's try yourself. Answerable question. Yes, yes ma, what is the answer? So now see 8 pages are there, 0 to 7, page number 0. Generally what is the page size given? 1K words are there, page size, right? So you take page number 0, has the word number 0 to 1023 or not? So page number 1 will be there from what? 1024 to, so 2047, correct? Page number 1. So page number 2 present from 2048 to 2048 to 1023, right? This value is 1, this value is how much? 7. So 3071. What numbers? Page number 3 has 3078 to 4095, correct? Like this we can see now. Okay, now see page number 0, block number 3 telling page number 0. So now this is page number 0. So page number 1 I don't have, correct or not? So now this 1024 comes under page number 1, that is corresponding frame number not there, means page number 1, is it present? For this page fault will generate or not? Tell me. For this reference page fault will generate or not, all of you? 1024 when I given, page fault will generate. Does page 1 is loaded into main memory? That not given. One reference generate nothing but I can eliminate this one. Even 1, 2, 3, 4, 1200 also present page number 1 only. This becomes a page fault, I can eliminate it. 2021. So now page number 1 available, but here you see this one, one more thing, 4050 present it. 2021 present where? 2021 present in page number 1 only, correct or not? So I can eliminate, correct or not? Yes or no? So 1020 present in page number 0. So page number 0 means, so I can go block number 3, I can get it, right? Yes or no? This is okay. 3012. So 3012 present in what? P2, P2 also it, P2 is there, page number 2 is there, yes, I can get it. 6112, can you tell me 6112 pointed to which page number? 6120 point to which page number? I hope 810 is a page number 7, 7 is present. I think this is correct only. 6120 pointed to which page number? So page number 4 is from 4096 to 5000 change. Page number 6 is 5002 or 6000 change. Page number 5, yes, page number 5 is present. I think page number 5 only na? 6120 page number 5 only, correct or not? So that is there, this is 7, correct or not? Yes, therefore option C 100% right. Very good, very good, very good, very good. And also some more problems you solve with translation logical to physical address like this in terms of decimals. Carefully, some problems you practice it in this area. Okay. So next question. Again, can you try this question? My interesting question this one is. It is virtual memory based one, virtual memory based one. Paging like under demand paging environment. So demand paging system takes 100 time units to service a page fault, 300 time units to replacing dirty page, memory access time given 1 time unit, and the probability of a page fault is P. In case of page fault, the probability of page being dirty is also P. It is observed that average access time is 3 times time units, then the value of P they are asking, value of P. Try. Yes, my dear all, try to solve this question, straightforward question only. So in this case, some couple of problems like a little distinction, like different with the values, you should try to practice it, because this area also we can expect. Yes, anybody tried? Got the answer? So effective memory access time with respect to demand paging will be, you have to understand, if there is no page fault, right, I am taking 1 minus p. This take m unit of access time. If there is a page fault, okay, I need to take what, dirty rate. If it is a dirty D, if it is a dirty D, they are given 300 time units. So 1 minus dirty, there is a clean place. So we required 100 time units, correct? 100 time units service a page fault, and 300 time units when you replace page dirty. So memory access time is what? 1 unit of time given now. Effective memory access time also given. What is effective memory access? 3 time units. So this 3 equal to 1 minus p into 1 plus p into, so the dirty itself p only given, this 300 plus 1 minus dirty is nothing but 1 minus p into 100. So this only expression, right? This only expression, all of you. Is this the expression? Everyone try to answer it. Expression is correct. So when there is a page fault, you have to go to bring and main memory, but when there is a page is dirty, write backing required, so that it will require more time. Should be very careful. Sometimes they will give on a disk access, 2 times of disk access will come sometime. But here it clearly mentioned total value is 300. It is easy question. But some more also they can ask, no, only IO disk access given. Such cases you have to add that values, 2 times of that value should add it. So what is the answer you got after simplifying this one? Carefully simplify this one. Yes, JP, Pardasarathi. P value, how much you got? Vinay, so Vinay, you got option A. So did you simplify properly? 0.0194 you are telling. What about JP? So you simplify it, you simplify it, you will get one of the option, right? Option A is sure. So next question, we will move on to next question. Try to answer this question, everyone. Consider a machine with a physical memory of x GB, page size is 8 kilobytes given, and 9 control bits in page table entry. Size of each page table entry is same, and the memory is byte island fashion. How many levels of page tables would be required to map 52 bits virtual address space if every page table fit into single pages? Every page table can fit into a single page. So now each cases, now case number 1, when x equal to 8 GB, when x equal to 2 GB is given now. So 0.0194, so 195 is nothing but option A only correct, option A only correct, yes. So try this question, take the screenshot of it. It is also interesting question. They are asking number of levels. So you know, right, number of levels, how to calculate, right? Number of levels of page table required to handle this virtual address, what, 52 bits given now. Virtual address is what, 52 bits. Suppose if I want to know first level page table, I am just taking here, I need a frame bits, right? I want to know number of frames. So number of frames, that is m equal to physical address space. How much physical address space? When case number 1 I am taking, for case number 1, 8 GB by page size how much? 8 KB. So 1K cancel, 8 cancel, this is nothing but 1M, correct? 1M frames are there. That is nothing but 2 power of 20 frames are there now. If 1M frames are there, frame bit number, frame bit value, frame bits are 20 bits, correct or not? Therefore, page table entry should containing 20 plus, now they said na control bits, 9 control bits, 9. So this 29 bits. Always page table size express power of expression what in terms of bytes. Now 29 bits nearest how many bytes? Isn't it 4 bytes? Page table entry value 4 bytes or not, all of you? 4 bytes, correct or not? Page table entry is 4 bytes now. Now come to the point of first level. Okay, first level page table. So page table size I want to know. That is nothing but n into what? E only, correct or not? Number of frames, number of pages nothing but 2 power of virtual address 52 by page size is what? 2 power of 13 bytes into what? E is what? 4 byte. This value is how much? Byte cancel. 2 power of 54 minus 13 byte, correct? So this value is how much more? 10 means for 30, 44 nothing but 39 bytes. This is a first level page table. Am I right, all of you? Am I right, first level page table or not? So now again I have to apply second level page table size. Second level page table size 2 power of 39. So 39, 42, 52, correct or not? Yes. 54 minus, sorry, wrong. We did wrong. So this value will be what I can say 10 remove 44, 41. So 2 power of now 41 bytes divided by what? 2 power of 13 bytes page size into entry size is 4 bytes. Correct. So this value is how much? 43, right, minus 13 unit is byte, correct? This byte cancel. So this will be there. Now this for 43 means what? You can say 30. 2 power of 30 we got 30 bytes. This is second level. Third level page table. 2 power of 30 bytes by 2 power of 13 bytes into 4 bytes is equal to 2 power of 32 minus 13 bytes, correct? This is 22 nothing but 19 bytes. 19 bytes required. So next fourth level page table is equal to 2 power 19 bytes by 2 power of what? 13. So byte cancel. This value is how much it will be there now? Okay. This is what you can say 9 minus 3 6, correct or not? 6 into 4 byte. So 2 power 8 byte. So 8 byte means last level has less entries, correct or not? So now number of levels. So levels is required how many now? 4 levels when x equal to what? 8 GB, correct or not? 8 GB. Total 4 levels, all of you, 4 levels, correct? 4 levels, correct or not? Now case number 2 is given x equal when 2 GB is there. Can you try? For x equal 2 GB, how many levels required? Main memory, right? X nothing but what? Main memory only, right? So when main memory changes, will it changes any levels of page tables? Think. So now when I am taking x equal 2 GB, number of frames will be, how many will be there? Now 2 GB by 8 KB, so 1K cancel. So this how many will get? 256K. 28, 256K only. So no, even more. Now 256 M. So I am writing number of frames because I need frame entry value I need, right? I need entry value I need, correct or not? Entry value I need. So number of frames when x equal to 2 GB, so 2 GB I am taking, number of frames equal to 2 GB by 8 KB. This 2 power of 31 by 2 power of 13 bytes, byte cancel. So 2 power of 21 nothing but 2 power of 21 only, right? 2 GB only given now. Yes, 2 GB means first one is what, 8 GB. First one is what, 8 GB, 8 cancel, 1 million we got, right? 1 million we got. Correct only. Now this value is how much more? 21 nothing but 18, right? 18. So now 18 bits required. F value, F bits are 18 bits, correct or not? So page table entry, so 18 plus what, 9. 9 only na, control bits given. Control bits are how many? Control bits are 9 bits only, right? 9 bits only, right? 9 bits only. So this value is going to be how much? 20, if I add it, 27 bits. So 27 bits nothing but again 4 byte only na. 4 byte only, correct or not? Either main memory is 2 GB or 8 GB, page table entry came here. 4 bytes only came now. So now number of levels, how many required for this now? Suppose number of levels will changes with respect to virtual address space or physical address space? Observe. With respect to virtual address or physical address space? Respond. Number of levels. Again 4 only will get. Yes, 4 only will get. Please understand. 4 only. It won't affect, correct or not? It won't affect on this one. When main memory changes, it won't affect. Because virtual address bits are 52 bits only, correct or not? So therefore what option? Option D, 4,4 required. Yes, ma, how many people comfortable? It is not with respect to physical address space, with respect to the virtual address space only. If virtual address space reduces, definitely number of levels will reduce. If physical address changes, what happens, page table entry size may changes because number of frames vary, entry size may change. That is not much effect on the levels of page tables. So I hope this is clear. So now try to attempt next question. Yes, JP, correct. Yes, ma. And a machine with 32-bit address and OS uses two-level page tables. Two-level page tables given. Each with 2048 entries are there. Very nice question, ma. You should answer everyone. Suppose a process has a text segment that needs 64 MB and a stack segment occupies 128 MB. Data segment requires 32 MB. Assuming page table entry size 4 byte. The space KB occupies the page tables of that process is dash. Now total page tables occupied. You can calculate the total number of page tables, multiply by page table size, you do total space occupied for a page table, we can answer it. As we know, generally program as text section, code section will be there, data section will be there essentially, stack area will be there. They given here. So what I can write, one is what text section, text segment has 64 MB. So second one has stack segment occupies 128 MB. Third one, data segment is 32 MB. Now page size given, what is page size? Page size given? No, not given I think. Page table size No, yeah, entry is given here. Entries, number of entries in a page table given, and page table entry size also given. Yes, you can answer it. 32-bit address, OS users. You have to find first question. You should find page size. You should find out, correct or not? You have to find out the page size here. You have to find out the page size. Can you tell me what is the page size? Yes, all of you. Try it out. Question number 1. Page size. Find the page size of a process. Bah, very good, ma. Very good. Very good. 1 KB is very good. How to understand, sir? So, machine 32-bit address is there. So, 32-bit address they said 2-level paging. Okay, 2-level paging. So, how to split this one now? 32. So, 2-level, first level, second level, correct or not? This only na 2-level. Here is offset will be there. Offset nothing but this only page. They said number of entries in each level 2048 nothing but always that's 11 bits required for this na. 11 bits required, 11 bits required. 22 over. So, for this how many will be there? 10 bits only. So, 10 bits nothing but can I get it? Page size equal to 2 power of 10. So, unit is byte 1 KB. Yes, too good ma. Very good ma, very good all of you. Now tell me. So, now how many page tables required? So, 11 plus 12 for large. Very good, very good. So, now answer this question now. Total memory space required for page tables they are asking. You calculate how many page tables required. Then multiply by page table size which we know. First of all, if I want 2 level means I should know at least inner level. How many inner level required? Outer is only one. You tell to occupy this much data to store in memory. How many inner level page tables required? To know inner level page table, I must know how many pages, frames required to occupy this one, correct or not? So, now I am asking here, okay, so I will write here point, sorry, I will write here. First case, code section, right, text section. So, text section or text segment, number of, so pages required. So, number of pages 64 MB. So, 64 MB page size is what? 1 KB. So, KK byte cancel, you will get what? 64K frames required, correct? It is going to occupy 64K. 64K frames is going to be occupied. Am I right or not? Now, see my point. To store this many entries, how many page table, how many inner page table required for this? Can you tell me? So, number of inner page tables required for this one, because this frames stored, those entries only inner page table I should have, right? So, one inner page table having how many entries? 2048 nothing but 2K only. So, now 64K by 2K, it is not 32. Hello, all of you tell me, 32 inner page tables required. Inner page tables required. So, now similarly for stack section, stack segment, so number of frames, so number of frames equal to 128 MB by 1 KB. This is nothing but 128K. So, now for this number of inner page tables required 128K by 1 page table can occupy this one. So, 64 required. Similarly, third one, data section or data segment. So, number of frames to load this program into memory. So, this size is how much? So, data is 32 MB, right? 32 MB by 2K. Sorry, this is 1 KB. Page size is 1 KB, correct or not? So now 32K required. So number of inner page tables equal to 32K by, so 2K. So we'll get what, 16 required, right? 16 required. So now 16, 64 and 32, correct or not? 32. So now number of total number of page tables required. One is outer. So in inner how many required? 16 plus 64. 16 plus 64 plus 32, correct or not? 32. Total how much ma? 96, 112, 113. 113 correct? Now total space. So total space for page tables. So 113 page tables required, each having how many entries? 2 power 11 entries. Entry size given. What is entry size given? Entry size given 4 bytes. Makes sense, all of you? So 2 power 2 you can write it. 2 power 2 means 2 power 13. So 8 KB into 113. This value can you tell me now? Very good JP. 113 page tables. Page table size. Each page table entry having 2 power of 11. So entry size is what? Total memory space I required, right? All of them. In terms of bytes you tell 904K. So what is the question they are asking here? Assuming this one, the space KB occupied by the page tables for this process is, okay, 904, very good. So 904 KB, yes. Question understood all of you? Question is good? Everyone. Chalo, move on to another question. Take it homework, you can try very nice question this one, okay. Again I asked like no, consider a 36-bit virtual address, 38-bit physical address. Each page table has 5 control bits. System employed multi-level page table structure and size of the page memory is 2 KB. Maximum number of page tables that can be associated with this process. What is the process size now? So process size is equal to 2 power of 36. So 64 GB size. One question I asked, did you remember? 4 GB process is there, how many maximum table required? I asked now, we answered 1025, level 2, level 1 we have taken, correct or not? Hello, one question we solved, 32-bit architecture time, I asked how many maximum page tables required? Now here is maximum process 64 KB architecture, information is given. Now 3 level 3, level 1, like level 3, level 2, level 1. Level 1, level 2 calculate, level 3 calculate, you will get answer. I am giving answer also, this is answer you will get it, but you check. Can you try this question? Take the screenshot. You must try after the class. After the class you must try. Is it not process size? This is a process size or not? Now you try to get the page table entry value. Page table entry value generally F plus some control bits given, control bits 5. Find the F value, page table entry you will get, you can get it. You can do other things. Easily you can able to do it. Try. Another question. Can you answer this question? Which of the following options gives the correct number of page faults related to LRU, FIFO, optimal page replacement algorithm with respect to assuming 5 page frames? Initially frames are empty. Can we do it or not? So this also work out ma. Take it homework, you can try this directory question, because why I kept, why I kept this question, it is easy. I am telling one of the easiest topic from operating system is page replacement algorithms ma. We can expect the 2-mark question. So last year there was no question from this area. Be prepared, may come, I am saying that, may come for 2-mark question. So directly page replacement was there, not the last 2 years. 2023 some indirectly they framed it, but 2024 there was no question here. Chances are there. Prepare easy area. You can just note this question. We'll see some more part, because time also running out. Now can we answer this question? Which of the following is or false? Which of the following is or false? Some theoretical statement. If the dirty bit is set, the reference bit must be set. Is it true? If dirty bit 1, what is the dirty bit? To implementing the demand paging environment, we keep the dirty bit, correct or not? If the page is modified, you have to write back to disk. If the page is not modified, simply delete it. If the dirty bit is 1, should I make it always reference bit is 1 also? Think and answer. Reference bit you might have studied, replacement algorithms, like a second chance algorithm is there, clock algorithm, correct? In a clock algorithm we use a reference bit, clock replacement algorithm we use a reference bit, correct or not? Is it true? Please think properly. If the dirty bit is 1, is it required to keep reference bit always 1? Suppose I am using optimal algorithm. Do I need to refer it? Maybe I am using LRU. LRU practical implemented one. In LRU, do we have reference bit? Least recently used one. Time of reference will be there, no reference bit, correct or not? I can go the demand paging environment, LRU replacement algorithm, can I go or not? So suppose if I am not bothering of performances, demand paging with the FIFO algorithm, can I go? Can I implement FIFO algorithm? Performance may be less. Can I implement or not? FIFO algorithm, all of you. Tell me. So it is not always true, please understand, this is a false statement, It is not compulsory. A dirty bit and reference bit are the minimum information bits needed for demand paging environment. Is it true? Option B. To implement the demand paging environment, do we need dirty bit plus as well as reference bit? Again see, can I implement dirty bit with FIFO algorithm demand paging? Can we implement demand paging by using what? So anyway by default dirty bit is required. Without reference bit also can I implement or not? Therefore this also false. That's what seems to be true. Carefully understand now. It is not necessary. Is it required to apply always clock algorithm or second chance algorithm as a replacement? Is it? So can I implement LRU? In case of LRU, time of reference we have no reference bit. Yes, only dirty bit is sufficient. Now use of reference bit be avoided if the system maintains alternate data structures. Think, suppose you not a clarity, you read. A page that is as dirty bit is set to 1, reference bit is 0, is a better choice for replacement considering another page has a dirty bit 0 and a reference bit is 1. You tell him now. He is saying that dirty bit is 1, reference bit is 0 is there, is a better choice to choose that page into replacement rather than when dirty bit is 0 and reference bit is 1. So which is it true? Is it true? Should I go with when dirty bit is 1 and reference bit is 0 for replacement? Is a better choice to select for removal? Is a better choice? Which one is a better choice? When dirty bit is 0, reference bit may be 1. Suppose but dirty bit is 1, if you choose on that page, you have to write back, correct or not? You have to write back or not? Listen carefully, listen carefully. Suppose when dirty bit is 1, reference bit is 0, means not referred. Is it true? Reference bit is 0, meaning our reference bit is 0. It is not referred is telling. Is it possible when dirty bit is 1, reference bit is 0? Dirty bit means what? It is already referred, correct, already referred and modified the data, correct or not. If that is the case, happen assumption, if you selected this page for removal, you have to do write back, additional overhead or not. Rather than if you selected what? A dirty bit is at 0, correct or not, is not better choice. So this also false, this also false. So come to the point. Use of reference bit can be avoided if the system maintains an alternate data structure. So reference bit, if you have a reference bit, example what I am trying to say, enhanced second chance algorithm, correct or not? Yes or no? So I can implement linked list, I can implement what with queue data structures, correct or not? Yes, this will helps to what avoiding the alternate data structure. Yes, this statement can be true. Option C can be true. So this way we can select it. So this way we can select the statement. Note, it is important part. Just take the screenshot of it. Take the screenshot of it. It's done. Okay. Now try to match the followings. Demand paging. What is the swap prefetching? Page replacement. Like no, this has to come here. If a program ends, the operating system delays freeing its pages. Yes, yes. So what is the mapping here? OS periodically write back the modified pages into disk even though they may be modified further. Keep on what you can say, page fault on referencing a stolen page, restore the corresponding page frame. If a program ends, the operating system delays freeing. Program begins execution within no pages. So that can I map it this one? A program begins execution with no page in memory. That's nothing but can I do it? Swap free page. Demand paging, can I map to this one? Can I map P2? Yes, all of you, can I map to P2? Swap prefetch means what? The OS periodically swapping, write back to this. Swapping nothing but you have to write back, correct or not? So I can map to this one. P1 I can map. If a program ends, the operating system delays freeing its pages. Pre-cleaning, correct or not? Pre-cleaning corresponds. So the page fault on referencing stolen page, restoring nothing but we are reclaiming only, correct or not? Therefore, S3 I can map it like this. R4, S3, yes. So this way we can map. Yes, yes. Note down this question. Note down this question. Note down this question. Done? Noted down? So come to the point. Among file system, it is a very easy topic which you have studied. Just focus on this in this area. Directory structure will be there, right? So directory structure and followed by inode structure related problems, try to solve it. Inode related problems you try to solve this. Followed by allocation methods we have, correct or not? Some theoretical things, allocation method like disk space management. So contiguous allocation, non-contiguous allocation, indexed allocation, theoretically just observe it. And followed by disk scheduling, easy topic. So disk scheduling is an easy topic, you should cover it. And physical structure you will study from computer organization point of view, revise that I will take. Yes, free phrase management. but never asked from this one. Most important things can be seen like this. These are the things can be seen like from this one. So try to revise this topic. That's sufficient, ma. That is sufficient. Okay, because I have not taken the solo questions for related, because that is solvable only. Majorly students face issues on memory management, IPC synchronization. That is the reason I emphasize more on that area. I hope you enjoyed these sessions, ma. So I hope this session definitely might have utilized to you. Okay, so this we also, you join this Telegram group. So what we can do it, this PDF is shared tomorrow itself only. You can take this PDF also, all of you. Okay. So now point coming into the point here, yes, ma. And as I told you in the next week. So next week itself, computer organization architecture, I am going to take the session, and try to join the session, utilize it, because where I am going to discuss clearly cache address things and instruction format, role of addressing mode, instruction pipeline, much important topic, floating pointer, even much important topic, correct? So that I am going to discuss. So the date will be Tuesday, ma. So then you can see 4 I think 24th. So 24th I am going to take this session. Okay. So all of you please understand, those who attended, not attended, later try to watch these 2 sessions. I have taken 2 sessions on operating system. So in which a major important topic related questions I have discussed is going to help you a lot. We will see that sessions coming when, just follow it the session, ma. We will look into that one. Okay. All of you, thank you so much.